Great. So first things first, oh, I continue. Annelise had actually a bit of a longer title for this, but I would just generally call this the Lipid Energy Model, a work in progress. And I'm gonna get this working, here we go. So I'm actually gonna be covering quite a lot, but I think I structured this pretty well, so hopefully it'll maximize retention. I'm not even gonna list off all of these because we're about to go into it. But this is me, and this is kind of a basic bio. I'm a senior software engineer and business developer. I've been architecting software platforms for over 3 decades, and the last startup I partnered in was bought by one of the largest gaming companies in the world. So I've done pretty good, and this kind of actually set me up to have a decent nest egg to do what ended up happening next. This is me now. I started a ketogenic diet in April of 2015, and I have to say, for the first 7 amazing months, I felt better than ever. And then I got some cholesterol numbers I was not happy to see. My total cholesterol had actually jumped to 329. And this really kind of put me in a little bit of a state of depression. But I was very happy with the ketogenic diet, so I started studying everything that I could find on cholesterol and the lipid system. This is typically collectively known as lipidology. And what I found was actually a pretty familiar pattern. See, as a software engineer, particularly a systems engineer, I tend to work on networks. And indeed, that's what the lipid system presented to for me. I mean, I'm going to be talking about a lot of the different aspects of this, but let's just say that there are many things that emulate, for example, having headers or having packets, many ways in which these objects talk to each other and form like cloud ops, things that I've already worked with quite a bit already. And so I threw myself into what I think a lot of people would call biohacking, but I would refer to as citizen science. I started taking all kinds of measurements to, I think a lot of my friends would say, an obsessive degree. In fact, a good example is that I actually photograph every single thing I ingest. When I say I photograph everything I ingest, I mean not just food and specialty beverages, but I mean also water, supplements, even gum. If it's anything that could have any impact on my markers, it's something that I'm going to capture. I actually looked this morning, and I think I have 47,000 photographs in the 4.5 years since I started. And this, by the way, is matched with, this is not hyperbole, 126 blood tests in the last 55 months. And these are actual blood draws, as in I went to LabCorp, actually got them drawn. And they all include an advanced lipid test known as a nuclear magnetic resonance test. And that becomes very relevant in the research you're about to see. So this is really kind of what got me started. I call it the inversion pattern. And here's sort of the story behind it. See, those first 8 blood draws, that actually happened over 3 months' time. So we're talking November 2015 to around the beginning of February. And what you'll see here is a graph where it's a 3-day average of dietary fat versus LDL cholesterol. And this is a relative comparison. So on the left side, these are grams of fat. And when I say relative comparison, you see that it doesn't start at 0. And this is against, on the right side, LDL cholesterol in blue. So what I noticed was my LDL-C going up and down like this, actually, because I was already tracking my food so closely, actually lined up inversely with my 3-day average of dietary fat, which you see in this dashed orange line. And that got me pretty excited to consider trying an experiment. So I colloquially call this the week of needles, because for 1 week, I quite literally had my blood drawn every single day. And I did it against a pre-planned food. This basically was eating the food to try to induce this particular pattern, first having low amounts of fat and then having higher amounts of fat, to see if I would get a likewise reflection in my LDL cholesterol. And that's actually just what happened. And then, of course, for data point 15, I decided, what the heck, let's step on the gas. Let's actually see if I could bring my dietary fat way up to see if it would bring down my LDL cholesterol. And that too is what happened. It actually brought it way down. Now, I'm not going to go through all the experiments since then, but at least in the ketogenic context, these are all 29 of my first blood draws in that context. And as you can see, this inverse pattern continues. In fact, to make it a little more pronounced, I'm going to flip this left axis over here. And you can actually see, now that it's flipped, just how tight this inverse correlation actually is. The Pearson is negative 0.8, and its regression is 0.648. It's really remarkably tight. If you want to see the scatter plot, it looks like this. This will also be in the slide deck. I call this the dietary fat inversion for LDL cholesterol. And indeed, the resulting LDL-C tends to be very predictive against the last 3 days that I was eating beforehand, and in particular, the dietary fat. So to go back to my graph for a sec and to still keep this inverse, what I'm saying is each of these couplings basically could be looked at this way. I'm recording this on the morning of a Friday, so to give you a real world example, if this is Friday, what I would do is I would look back to the day before, which was Thursday, yesterday, the day before that, which is Wednesday, and the day before that, which is Tuesday. And those 3 days together would be highly predictive inversely with what my morning LDL cholesterol test would be. And to really kind of drive this point home, I mean just looking at those 3 days and not looking at, say, days 4 and before that. That's pretty powerful. But on top of that, this also applies for LDL particle count, low density lipoprotein, or LDLP. Interestingly, though, it's with a 2-day gap. And I don't have enough time in this lecture to get into my physiology hypothesis on this, but in effect, if we were to use the same pattern, rather than looking at yesterday, Thursday, and the day before that, Wednesday, I would start at Tuesday, the day before that, Monday, and the day before that, Sunday. And I actually have that reconstructed in the next graph. Only this time, this purple line represents LDLP in relative comparison. And now this dashed orange line is the 3-day average of dietary fat, but with a 2-day gap. So this is what the new reconstruction looks like. I'm going to flip this axis again so that you can see this inverse tracking. And as with the LDL-C graph before, it doesn't track perfectly. There are some gaps in some places, right? But it still has a remarkably tight correlation. The Pearson even a little bit tighter at negative 0.81, and the regression at 667. Okay, so what happened next is I got an experiment going. I actually got a number of people to do this with me at a conference. And here's how it worked. Basically, I instructed everyone to say, hey, let's go ahead and be either low calorie, low carb, high fat, all of them were on a low carb diet, or just straight up fast for the first 3 days. We'll have a 12 to 14 hour water fasting overnight, and then we'll do the first 2 blood tests, which is on the morning of July 14th. This is in 2017. Then everybody can go ahead and eat as much food as they want. In fact, even better if you could have lots and lots of saturated fat. And then another 12 to 14 hour water fast for the overnight, and a final second morning blood test. And I posted the hypothesis in advance and said, following the second phase of the higher dietary fat, I predict the resulting LDL cholesterol for the majority of participants will show a decrease when compared to the first. Here are some photos from the road. I'm very happy that PTS Diagnostics helped me out with this. They both helped us take measurements with their cardio check, but also to do lab draws for both LabCorp and Quest. And this is now a graph that I like to call the broken ladder. As in, you can see this represents all of the different data points for people's LDL cholesterol when they started on Friday, 7/14/17. And then this is 3 days later on Monday, 7/17, after the intervention of having a lot of high fat throughout the festival. And indeed, we have 19 of the 22 had a decrease of between 5 and 38% of their LDL cholesterol, whereas just 3 had an increase of 1 to 2%. So about an 85% success rate, which anecdotally seems to be what we see when people report it in at our website. This is also shown here, and the average change is LDL-C of about minus 16% across the board, and a drop of about 25.7 milligrams per deciliter. I think some audio is going on somebody. So you can see here that actually this is reflected in all the different rows in which we've got blue. That's everybody who saw a drop in the LDL-C, while those in tan are where we saw that small increase. So consuming a lot of fat while on a low carb diet typically results in lower LDL-C from baseline. And I do want to emphasize baseline because, like me, many of these people had a higher baseline LDL cholesterol. But in this short span of time, their LDL-C would drop. Why? Well, this is really what got me started on what I like to call the lipid energy model. And I'm going to take you through 4 different parts of the energy model to try to kind of explain not just the inversion pattern, but what I think is kind of going on overall with the low carb diet and the reason in which you might have higher levels of cholesterol being detected. So let's go through part 1 of 4, but first a disclaimer. Look, many parts of this presentation for the energy model are simplified to provide general concepts. Many aspects are not covered in depth, such as insulin, glucagon, HPA axis, and ketone pathways, all of which are relevant to this model. I can speak to more of the nuances in our Q&A, and really, I can speak a lot more to that once our paper is out. But the point is, it's a presentation. Of course, I've got to simplify a number of things. Just wanted to put that forward. So let's talk about the 3 macronutrients you hear about all the time, which is carbs, protein, fat. And of course, you already know that carbs get converted to glucose, protein can get converted to glucose via gluconeogenesis. These are all simple molecules that are ready to get into the bloodstream. And we love to talk, especially in the ketogenic community, about how fat gets converted to ketones. That's why it's called the ketogenic diet. But I would argue that's a little bit deceptive because a lot of people feel like 100% of your fat gets turned into ketone bodies. The truth is, actually, fat has many other ways of getting direct delivery to your cells. It can be delivered via triglycerides on lipoproteins and also as non-esterified fatty acids. But I really want to focus, especially now, in this pathway and triglycerides coming onto on lipoproteins. And to do this, we need to kind of go through the lipoprotein lineages. Obviously, this is a boat, and I do this for not the savvy biochemical audiences you guys are, but basically I'm trying to drive home that it's a way to move something that's, of course, hydrophobic through an aqueous environment, which is your bloodstream. A chylomicron is one of these lineages. It's known for having an ApoB48 lipoprotein. That's part of what denotes it. It comes from your small intestine because of food you just ate. So I eat some food, have a lot of fat in it. It gets packaged into a chylomicron, and it's very bloated with triglycerides, just like a little bit of cholesterol, which isn't represented here. But the main point is these triglycerides are distributed to my peripheral tissues throughout my body. And very quickly, and I mean in just minutes, this becomes a chylomicron remnant and gets quickly absorbed by the liver. But this is counterbalanced with another lipoprotein, which the liver makes. It makes VLDLs, which also have a lot of triglycerides and also dilipidate, dropping off a lot of their triglyceride cargo through my peripheral tissues. And I would call this category the energy delivery category. Now, this isn't the only thing that lipoproteins do. They also have a support role. And this brings up a very famous supporting lipoprotein known as HDL, high density lipoprotein. And indeed, this one, particularly the cholesterol on board, is associated with better cardiovascular outcomes. Now, I would also argue that there's another famous lipoprotein, which we've all heard about plenty, LDL, also comprises a support role. It's a little less known, but in fact, it actually has lots of involvement in the immune response. It binds to pathogens. It provides alpha tocopherol, known as vitamin E. It can be endocytosed by your cells for constituent components and so forth. But let's just, for the moment, for the sake of argument, say that it's part of the support role, and we put this all together. We see that basically we've got one category of energy delivery and across the dotted line, support. So energy delivery, support, and then one more time, energy delivery, support. And what I'm trying to draw attention to is that there's just one lineage of lipoprotein, the ApoB100 lipoprotein, that is pulling double duty. VLDLs are providing energy. LDLs are providing a support role. Most of the lipoproteins that are leaving your liver are going to be VLDLs. And around half of those are going to be absorbed as IDLs to the liver, but another half are going to remain as LDL particles. And what will help this make a lot more sense in this context is when you look at this in the context of time, which if we're looking at the VLDL to LDL life cycle, we see that VLDLs, they last around, say, 30 to 60 minutes. And as IDLs, less than 30 minutes. This is just representing in pixels. What's the rest of this time? What does that account for? About 2 to 4 days as an LDL particle. So put another way, about 1 to 2% of the stages for this ApoB100 are going to be as a VLDL or an IDL. And if it's not absorbed by the liver, the rest of the time, 98 to 99% of the time, it's going to be as an LDL. And I think it's no coincidence that this is roughly a 2 to 4 day residence time when in fact you see that that inversion pattern includes about a 3-day window. So with that in mind, let's look again at this, but let's go ahead and actually add an additional column, which I'm going to call remaining. Because again, these being simple molecules, effectively, they don't really have anything remaining like they do, say, a lipoprotein, where if you are trafficking a lot of these VLDLs, you're going to have a low density lipoprotein remaining. And in fact, if you're trafficking a lot of VLDLs, it makes a lot of sense why you would have a lot of LDL particles remaining. So to kind of drive it home, I'm going to take it back to this graph with the LDLP cholesterol. I'm going to say, okay, what if I'm in a hypocaloric state on a low carb diet, or I'm just straight up fasting, right? Well, then that means that there's few incoming chylomicrons. There's probably less glycogen stores since I'm on a low carb, high fat diet. Therefore, it necessitates more lipolysis. More lipolysis brings those fatty acids into the liver to drive greater VLDL secretion. And thus there's more LDLs resulting. Conversely, let's say I'm eating lots and lots and lots of fat, lots of incoming chylomicrons. And that necessarily means that there's less and less VLDLs that need to be trafficked to provide the energy, and thus less LDLs resulting. So let's talk about the next part, because I want you to think about this from the staging and pacing standpoint of the energy itself. Now, I'm taking this graphic actually from a great paper, Fatty Acid Metabolism in Adipose Tissue, Muscle and Liver, and Health and Disease. And what's great is they sort of break down the inputs of both of these categories of adipose tissue and skeletal muscle in particular, which I'm really interested in. For example, in the input for adipose tissue, if you were to go to your adipose tissue right now and you were to say, hey, how much of the fats have you gotten from triglycerides that were onboard lipoproteins? I'd say about 90%, 45 grams a day, relative to the 5 grams I get from NEFAs, non-esterified fatty acids. Conversely, if you look at skeletal muscle, it's almost a flip. It's gotten just 10 grams a day from triglycerides onboard lipoproteins. It actually gets twice as much from non-esterified fatty acids. This is a flip from its neighbor nearby. And that's because these non-esterified fatty acids, they're mainly coming from adipose tissue. And so to kind of drive this home with an analogy, you all know FedEx, and you know FedEx has a lot of packages it's getting around to these local facilities. And then these local facilities, they have smaller vehicles that are delivering these packages out to your homes in the neighborhood. But you can kind of think of this as the global distribution chain, right? You can think of this as the local distribution. So if we flip this, we're looking at VLDLs and chylomicrons supplying their triglyceride cargo to adipose tissue, which helps with local distribution of these non-esterified fatty acids to cells. And of course, some amount of these are getting re-esterified back into adipocytes. So let's take this to the 50,000 foot view. And let's talk about this between a fed state and a fasted state. So what's happening in the fed state? Well, especially if I'm on a low carb diet, I have a lot of incoming chylomicrons and some residual VLDLs. And what are they doing? Well, of course, they're supplying some amount of energy to my muscle tissue, to my cardiac tissue, to organ tissue, et cetera. But on top of that, they're repleting my adipose tissue in bulk. Now, of course, eventually I'm going to get to the fasted state, hopefully between meals and overnight. We don't want to be in the fed state indefinitely. And what's happening is, of course, the insulin's going down, the glucagon's going up, and now adipose tissue is providing more and more non-esterified fatty acids, especially to nearby and adjacent tissues. And VLDLs are supplying some degree of direct delivery. But the important thing is to remember, even in this fasted state, we do still need to have VLDLs repleting the adipose tissue. I think I can't emphasize enough that this distinction is very important to understand. It's the wide availability of energy to cells that I consider to be crucial. The problem isn't one of total energy. The problem is one of energy distribution. Cells govern their energy status locally with limited individual control over the larger process. Thus, it's the role of the body as a governing system to make energy available to cells on demand, whenever and wherever it is needed. I can't emphasize enough that this is actually a very challenging engineering problem. If you think about it, your body is 100 trillion, give or take a dozen trillion cells. Most of them are nucleated, and they're expectant of energy. Well, the problem is if you were a diner with 100 trillion customers, you can't just have them order off the menu. What's easier to run than a made-to-order diner is a buffet. And a buffet is much easier, and the reason is because you don't need to watch the customers. You just need to watch the buffet line. And that's basically what our bloodstream is. It's a buffet line of energy. And that's a lot easier to solve, particularly if you have all of this subcutaneous fat all placed around the body. Then it's just a matter of constantly making sure that they get refilled to proper amount. So now let's get to 3 of 4, which is going to be the emerging lipid profiles. So naturally, you've got to ask, what about when you're metabolically inflexible? So let's go back to this top view, and let's say that you're kind of stuck in a fed state. And that doesn't necessarily mean that you're just literally eating around the clock. That could mean that your body believes it's in a fed state. For example, it's stuck with hyperinsulinemia. Well, of course, we have lots of data that shows that you end up with a lot more VLDLs, and you end up in something that could be called a maxed out pathological fat threshold. Some would call it a personal fat threshold. And what does this associate with? It associates with also an increase in ectopic fat. And again, this makes sense to me as an engineer, because there is one place you really don't want energy parked more than in tissues like the liver and the pancreas and the heart, where the ectopic fat goes, and that's in the bloodstream. That's very scarce space. So of course it has a hierarchy of affinity. You really want to be using your adipose tissue. You want to be using those adipocytes because they're the pros. They're great at staging and pacing energy. And that's why this could be so associated with disease. And that's why it comes with a profile that we know pretty well by now, known as atherogenic dyslipidemia. It's characterized by low HDL cholesterol and high triglycerides, along with a preponderance of small, dense LDL particles. The truth is, you could really just look at your HDL cholesterol and your triglycerides, and if this is low, this is high, you probably have a high preponderance of small, dense LDL particles. And yes, it's usually a pretty bad sign, and that's why a lot of people go on a low-carb diet, because oftentimes it can help with that aspect in particular. Indeed, this is highly associated with hyperinsulinemia, remnant lipoproteins, ectopic fat, cardiovascular disease, and of course the mother of them all, one that I'm very interested in, which is all-cause mortality. But could there be a fat-adapted, flexible metabolic profile? Well, for that, I kind of want to bring up the counterpart to atherogenic dyslipidemia, which I regularly call the low-carb lipid triad. See, a lot of people who go on this diet, they'll often see their HDL go up. That's good. They'll see their triglycerides go down. That's good. But then, and ironically, even when they tend to be healthier in general, they see their LDL cholesterol go up. And that ends up being a big sticking point. I sometimes humorously call this reverse atherogenic dyslipidemia. And sure, it's associated with low insulin levels, low VLDL, and low remnant lipoproteins. But will it associate with low ectopic fat, low atherosclerotic cardiovascular disease, and low all-cause mortality? That's the question. Well, before I get to that, let me get to the last part of the energy model. And this one's a little more esoteric, but it comes back to hepatic glycogen stores. And to kind of set this up, I want to take you through what I call the carb swap experiment. And basically, this is what I did. This was a few years ago. I had this be isocaloric. I was having 3,000 calories a day, 1,000 calories at 10 a.m., 3 p.m., and 8 p.m. on what is a meal replacement shake for a ketogenic diet. It's nutritionally complete. And the intent was for me to be able to have something that I could have very tight control over and for which there wasn't a lot of variability. For the first 3 days, that's what I ate. And then for my intervention, I had 500 calories in the form of carbs that came from bread, and then 1,000 calories the day after. And it was an isocaloric swap, so I still kept it 3,000 for both days. Then for another 2 days, I kept to just the shakes, and then I had to do some traveling. So we went to 2,300 and then 1,500 calories past that point, but it was still ketogenic. So this was the only period of time in which I wasn't ketogenic. So what happened? Well, as you can see, my total cholesterol at that time was still at that whopping high level that I told you about at the beginning, while on this ketogenic diet, 313, 326, 320. So you can see it's kind of hovering. And then you can see on day 4 and 5, as I'm adding in these carbs on the morning of, we can see that my cholesterol is starting to drop. I couldn't get a calculated clean LDL-C because if you're under 50 milligrams per deciliter of triglycerides, then you can't actually calculate it. But then here's where it gets interesting. I go back to the ketogenic diet, and yet my LDL-C continues, my total cholesterol continues to go down. My LDL-C, at the very end, ends up at about 131. And I believe that this had to do with raising my glycogen stores, which could ultimately result in lowering cholesterol. Why? Well, some studies and literature suggest that lower relative hepatic glycogen stores induce a greater rate of lipolysis. And this could make sense, given it will provide greater short-term energy buffering in place of the missing glycogen availability. This higher level of lipolysis could lead to greater VLDL secretion and thus more successive LDL particles. Now, I wanted to finish with one more experiment that I did that probably is the most talked about of the experiments. And with all of the rest of the energy model in mind, this will make a lot more sense to you. It's called the white bread experiment. What you're seeing in front of you is exactly what I was consuming and only what I was consuming. It was white bread and lean processed meat, along with water and some supplements to try to keep to some nutritional completion. And yeah, I have a whole bunch of pictures that look just like this. In fact, the reason I chose white bread and lean processed meat, which one of my friends jokingly called the prison food diet, is intentionally because it was low quality food, because I didn't want going from a low carb, high fat diet to a high carb, low fat diet to be a question of whether the food composition was better. As in, if I, for example, had lots of kale salads and so forth, it might be considered that there were other factors involved. And I don't think that there are. I think it's mainly about the energy substrate and the metabolic pathway. That's why I chose this. So in having lots of white bread and processed meat, what would this do in an overconsumption with my cholesterol levels? Well, on 9/20 of 18, my LDL was a whopping 296, coming off of a ketogenic diet and getting into this experiment, where I then flipped over to eating the white bread processed meat. You can see the day after that, it was 233. The day after that, 198, then 160, then 147, 102. And as predicted, in a time-stamped video that I made before I did this, I reached the lowest LDL cholesterol I've ever had at 83. 83, this ended up being a drop of about 213 milligrams per deciliter in 1 week of my LDL cholesterol. And while that might not make sense to a lot of people, I want to drive this home to what I was talking about before, in that indeed, instead of being powered by ketones and triglycerides, which might leave more remaining LDLP, I was being powered a lot more by carbs and possibly to some extent protein. Now, that's not the full story. It's not strictly what the metabolic pathway is. Obviously, there are other factors. For example, I was becoming hyperinsulinemic, therefore I was pinning in a lot more of those fatty acids and reducing lipolysis by over-consuming, as well as actually repleting my glycogen stores in the liver. So while I can make fun graphs like this with that experiment, this was the other graph I made with the triglycerides and HDL. You can see the triglycerides precipitously go up till I'm at around 221 on that last day. And I reached a record low 38 in my HDL. It kept continuing to drop to somewhere I'd never seen it before. Now, I've seen carb overeating studies where it showed that there wasn't that much de novo lipogenesis. I certainly do think that this 221 reflected at least some amount of de novo lipogenesis with me in particular. But, without a tracer study, I can't say that I know for sure. So this leads me to talk about the phenotype of a special interest to me and this model called lean mass hyperresponders. Kind of rolls off your tongue, right? And I apologize, but there's kind of a history as to why they're named the way that they are. So of those going on a low carb diet, you'll see that some will have this dramatic increase in their total and LDL cholesterol. And long before I became involved, many doctors like Peter Attia and Thomas Dayspring would call these hyper responders. But I started to notice that there was actually a very specific pattern that included the highest total and LDL cholesterol. And counterintuitively, they tended to be very lean and athletic. We call these lean mass hyperresponders. To sort of put this in perspective in a visual way, if this was a triad typical of those people who are hyperresponders, this is what I would say is the triad for lean mass hyperresponders. Now, very high HDL cholesterol and very low triglycerides, coupled with very, very high LDL cholesterol. And about 3 years ago, I wrote this article that included this graphic, which I'm going to take you through. And I posited that cholesterol scores can be higher for those who are lean and or athletic on a low carb diet. And the cut points that I gave, all three in combination, that this was seen often with people who I observed would have an LDL of 200 or higher, an HDL of 80 or higher, triglycerides of 70 or lower. Now, all three of these, if you look in the literature, all three of these are actually very rare in singularity. Like, it's actually very hard to find people who have an LDL this high and find anybody who has an HDL this high, triglycerides this low. And as I do with this model, I posited that perhaps this was lower glycogen stores in combination with lower body fat, and also in combination with higher energy demands from being athletic or active. Thus, lipoproteins may be needed to traffic a greater amount of energy from fat, resulting in higher LDL cholesterol markers. It's sort of funny, even now these days, I think of things I wish I could have said differently. And one of them is I would have said like energy potential instead of energy from fat. But anyway, this is the banner from the Lean Mass Hyperresponder Facebook group. So you know how I said how rare it is to even find those markers in an individual? Well, this is a group full of people now, lots and lots of people. These are unicorns, because these did not exist in these large data sets from before this point in time, before ketogenic diet became a lot more popular. And you'd be forgiven if you thought that this was a fitness group. It's not a fitness group. What brought these people to our group is their lipid numbers. And that's why if somebody gave me lipid numbers that looked like an LDL above 200, HDL above 80, and triglycerides below 70, without knowing a single other thing about you, I would guess that you're probably very low carb, you're probably lean, and you're probably at least fit, if not athletic. And the vast majority of time, people commenting a cholesterol code goes, yeah, that's right. How did you know that? Well, this is what I would posit is going on. But before I do, let me tell you what's common for the lean mass hyperresponders. They have low cardiovascular risk in having low insulin levels, low waist to hip ratio, as you've seen, low blood pressure, low triglycerides, low inflammatory markers, low HOMA-IR, and of course, high HDL cholesterol. So what's their high cardiovascular risk marker? There's just the one. It's a high LDL, which of course means high LDLP and a high ApoB in this case. So did this exist in the literature before? Well, there already were people who were kind of looking into this, including great work from Volek and Finney. And in fact, this study's from a couple years ago, where they studied athletes and they divided them between high carb and low carb. And indeed, we see that the low carb athletes, their total cholesterol would tend to be higher, their LDL-C would ubiquitously be higher. And as they state here, the observation that highly trained ultra endurance athletes consuming a very low carbohydrate, high fat diet exhibiting a more dramatic and uniform hypercholesterolemia is counterintuitive, since high volume exercise tends to lower total and LDL-C levels. And I can actually speak a little bit more to that in the Q&A, but there's an experiment that I did to specifically lower LDL just from exercise while keeping all other things the same. So this is what I posit in the energy model. And again, this is a hypothesis, but it goes like this. In a fasted state for these lean mass hyperresponders, we have a different situation than what I described above. we have lower total adipose mass. And because of that, we're going to need to traffic more VLDLs off the existing fatty acids. And that, by the way, also means more VLDLs repleting. And that's okay. From a systemic standpoint, this is actually something I'm used to with networks. All that's really happening is basically a faster version of load balancing. Adipocytes are already used to doing this. It's what they're pros at doing, and it's also what VLDLs do. If we thought this actually was putting stress on the liver, we would expect to see this, for example, with higher inflammatory markers like C-reactive protein and so forth. But we don't. We actually see extraordinarily low levels of C-reactive protein, and what appears to be, at least in the early data, to be very strong health for the liver, which I find to be very instructive. So, studies that help to support the energy model, I'm picking just a few. We actually have something like a couple dozen that we'll be using for the paper. Well, let me ask each of these questions and then provide one study to show you. Can fasting increase cholesterol? Well, yes, fasting increases serum total cholesterol, LDL cholesterol, and apolipoprotein B in healthy non-obese humans. And this is a multi-day fast. You can see that their total cholesterol goes up, their LDL cholesterol goes up, their ApoB goes up. Also, can high HDL-C levels relate to VLDL triglyceride turnover? Indeed, the concentration of high-density lipoproteins is related to catabolism of triglyceride-rich lipoproteins. So of all places, we're getting this from chronic alcoholic users. And you may not be able to see this because of the screen capture, but they had them drinking first and then actually checked after abstinence to see what their fractional catabolic rate is. And it does indeed go down, as does their HDL. And of all the interesting places to find for lean mass hyperresponders, are there examples of those with very lean mass and lower glycogen stores having higher LDL-C? We see this with those who have anorexia nervosa, so that oftentimes their total, their HDL and their LDL cholesterol can be higher. Now, by this point in time, if there's not already a queue full of this question, this is what's on a lot of people's minds, which is, that's swell, Dave, but what about the risk? Okay, isn't high LDL cholesterol always bad? And spoiler alert, as I say often, I don't know. In fact, there's a particular phrase that I like to say, which I don't have in here, which is, I like to say I'm cautiously optimistic in this context. And by saying that, I'm acknowledging the level of uncertainty, even if I have a leaning. So I am sure trying to find out for this context in particular, particularly for the lipid triad. One thing I'm a little bit semi-famous for is this graphic that I've circulated for some period of time, because I've sought to find any and all studies related to the lipid triad and its association with cardiovascular disease risk, especially in normal, non-treated people. In fact, I even went so far as to actually have a reward. So I'm willing to give away, for example, $1,000 to somebody as a kind of finder's fee. If they could find the lipid triad, specifically those things that meet this criteria, for which we see just even above average cardiovascular disease. I'm sorry this link is obscured, but you can just Google it on my site. But I wanted to provide it to you guys because you can all participate. The reward money is still outstanding. So there are, however, studies that do look at this triad that are showing the reverse. For example, this is from Framingham Offspring. And I really like the study because they exclude users of lipid-lowering therapy. It was 3,600 men and women. And what we find is that they stratified between high HDL-C and a low HDL-C. And unsurprisingly, those people had low triglycerides and low LDL cholesterol, below 100, actually had the best odds ratio of everybody on this chart. But what's interesting is you would have thought that if you flipped it and looked at everybody who had an LDL of 100 or higher, that it might be an odds ratio of 1.3 or 1.4, but it's not. It's 0.7. Even if you focus a lot on it being a 0.1 higher, the fact that the triglycerides being low and the HDL being high is quite substantial. But they even have further one where they looked at LDL at or above 130. It's still the same. It's an odds ratio of 0.7. Now, I would have liked a little bit better confidence intervals here, and perhaps we'll be able to get more studies as more time goes on because we'll get larger populations. But I did find this one to be pretty compelling. There's also this one, Jeppesen study, where they looked at a cohort 2,900 men aged 53 to 74, free of ischemic heart disease at baseline. And what I liked is they stratified between an LDL of 170 or lower versus an LDL of above 170, and then substratified within. So you can actually see HDL at or above 57, triglycerides at or below 97. When you compare these two, they're nearly the same. There's only 2/3 of a 1% difference. And that's pretty powerful. I mean, you can really see the stepwise fashion on whether or not you've got the HDL and the triglycerides. And indeed, even on the atherogenic dyslipidemic group, there's hardly any difference at all, whether or not you had high or low LDL. It seemed to matter much more what your HDL and your triglyceride levels were. I also just got into this recently. This is from the Jackson, Hart, and Framingham Offspring cohort studies. This is a 3D graph. It's pretty cool because what they're looking at is they're looking at HDL on the x-axis. And then on the y-axis, they're looking at remnant lipoprotein cholesterol, which I can't get into right now, but I'll just say it does very closely track with triglyceride levels. And then on the z-axis, they have coronary heart disease risk. So you can see those people with extremely high HDL, yet very low remnant lipoprotein cholesterol, are at very low levels of coronary heart disease risk. And you know who's over here? Who's over here right now from a profile standpoint are lean mass hyperresponders. Now, I'm putting my money where my mouth is. We're trying to get together a study. And over the last half year, we've been able to raise $174,000 toward a study on lean mass hyperresponders. I showed you that list before on how they have low cardiovascular risk markers across the board, save LDL. So they're almost like a gift to science in the sense that they're able to illustrate that one marker of interest that we want to know about, which is LDL, while taking out all the other pleiotropic confounders. So we're going to be capturing CT angiograms at the beginning and at the follow-up of 1 year later, along with wide spectrum blood testing. And our team includes people of differing expectations for the outcome, conflicting hypotheses for the risk level. I really love that. Spencer Nadolsky and I disagree on what we think we'll see, and we're very public about that. And I wish that there were more mixed hypotheses teams taking on a study. I think it helps the science a bit more. And Annelise wanted me to mention this, and I'm kind of glad that I never get to put this into a presentation, but I'm going to talk a little bit about my own personal process and ethics. And these are sort of 3 rules that I would love to be able to pass on to really everybody, particularly for those practicing citizen science. First of all, practice transparency above all else. All good science is honest science, in my opinion. And sometimes this means forcing you to be honest with yourself. I mean, if you're really transparent, it's kind of hard to, for example, get into p-hacking, right? Always endeavor to be cordial and respectful. If you go through my social media, you'll probably see this a lot. I try to avoid name calling, character attacks, personal insults, even as other people may apply this to you. This takes discipline, but it is, in my opinion, a truly worthy goal. And lastly, always seek productive criticism. We're really, really fortunate to live in an age of technology that allows peer-to-peer collaboration and debate. And honestly, some of the strongest opinions I hold today came from trying to defend my original opposing view and failing, sometimes comically. And that's it. That's my talk. Thank you guys so much.